Okay, guys. So, hey guys, welcome back to the channel. I'm going to just start, or this is going to be a quick review of an exercise that I did today. It's how to find max and minimum value of an array, or I'm sorry, of a linked list that was entered by the user. So, first thing first, we have to include the basic headers and libraries that we're gonna need in this code, which are the standard input and output and standard library for memory management. Now we're going to define our singly linked list, which is going to include one type of data, which is going to be integer type, and a pointer link to the next node. Now, jumping into our main function, we're going to ask the user for how many nodes they want to have. This is for in this program specifically. We're not going to place a condition on when to stop taking input and nodes from the user, but instead, we will ask the user to explicitly specify how many nodes they want to have in this program. Then here we start by defining our two, as usual, uh, struct structures or nodes, just for us to scan input from the user according to their input. After that, we always initialize them to null because they have no initial value yet, and we can't just leave them without anything. It's the best thing. It's an advice. Always initialize things to null if you don't have a value stored in them yet. All right, moving forward, we have to go to into our for loop, and this condition is the core because without it, if we didn't ask the user for to specify how many nodes they want to have, we would need to use a while loop. All right, now for because we got to get it counted here and etc. and all that. Now inside the for loop, we will have to define a new struct node that's called I decided to call it a new node. That will be the node the newly created node that will store the new entered value each time we iterate through this loop. And of course, how do we allocate memory for this node? By using this malloc function, and we need the size of this structure. So we're reserving in the memory the size of one integer, and the size of the pointers pointing to the next node. Now, as we already know, had equal new node is the basic, and we're assigning current to new node because we want to move from current. Current is going to be the traversal pointer, like this pointer helps us traverse the list. Uh, yeah, had equal new node, had equal null because this is the first node in the list, and current equal new node, else had is no longer equal to null. So we're assigning the current, which is a new node, next new node is pointing to itself, then it's equal to itself, and each time it iterates, it creates a new node again, and it points to null unless it points to new node if the value of I means the iteration count is still less than value. Now we have finished taking input from the user, and it's time to reset the counter, which is current, to head because we want to start at the very beginning of the list. Right now we have to initialize two integer variables, maximum and minimum, and both are starting at the very first beginning of the linked list. Like we can think of it just like an array. We're just by default saying that maybe the first element we have is the biggest one, and then we start looping and comparing. So yes, we do initialize the both two values, the both new integers to the very first value of the linked list, and we enter a while loop. Here we don't need this counter, So it's easier and safer to use current because the loop will eventually ends when what did happen? The loop will eventually ends when uh, the the user finishes input. So if current data, that means if the data in the current node is bigger than max, then max is this data. Okay, so if this data here is bigger than whatever data is in head, then max is this data. And same for minimum, but here was vice versa. We have to add the less than or less than sign. All right, and this also we're assigning if the element at current data, this node, is less than minimum, then minimum is this data. All right, in current. And now we have to keep looping all over the linked list. So uh, we have to insert this line, which basically says if it's easier for you, it's like I plus plus. This is the same or the equivalent from the for loop. We're just assigning current to a next value each time. Current is moving from itself to the next value. And now we're just printing. That's as easy as it seems. We're just printing the values, and we're resetting. Why we're resetting current to head always? Because current here is null, and if it didn't, or if it wasn't null, the while loop will be an infinite loop and won't stop. But we did research for one very important thing, that we have to free the memory every time. This is a very basic practice in C. When you allocate memory for any kind of data, you have to free them in the very or whenever you finish using those data. Or if you didn't do that, you will have memory leak, and eventually your program will crash sooner or later. So it's the best practice uh, to free your allocated spaces in memory when your program finishes. And we do that by storing the data in current, which is recently pointing to head, into a temporary pointer called temp. Then we assign the next value, or where current should points next. It's pointing to the next node. Then we're freeing this, and all of this while current different than null. Then we return 0. Okay, this is the program. Let's taste it and see how. Let's test it and see if it works. All right, how many nodes I want to have? Let's say I want to have 4 nodes. Now this insert data into node number 1. Let's insert random memory, and let's say max is 7 and minimum is 0. That is 100% correct. We can try it again, run it again with different numbers, different signs for numbers. We got 5 nodes. Let's try some negative numbers. Yeah, big numbers. Max is 9393 and minimum is minus 55. That is 100% correct. So yes, this program did work, and it did work with me from the very first time I wrote it. But to be honest, this logic here was flipped. I was comparing the data and max to current data. Uh, so it wasn't working correctly. Like max was minimum and minimum was maximum. But later I did figure it out myself. So that's it for today. It was a very short, clean, direct video. Thank you guys for watching. If you have done this before, please let me know which approach you have used in the comments below. Thank you for watching, and see you again.